So we're going to continue looking at square roots of non-perfect squares. So remember, the perfect squares will be your numbers such as 1, 4, which is 2 times 2, 9, which is 3 times 3, 16, which is 4 times 4, and so on. So these are our perfect squares. We're looking at non-perfect squares. Now remember, when we're looking for non-perfect squares, we're also going to be using these numbers, but if you look here, the square root of 25 over 36, we're going to write that as the square root of 5 squared divided by 6 squared. We also know that the square root cancels a square, so your answer is 5 over 6. So this is considered not a perfect square, but we are using the perfect squares in here to get our answer. So try to keep that in mind when you're doing the worksheet. So we'll start with the modeling first. So we'll do number B. So when we're looking at B, I'm going to enlarge this so it looks a bit bigger. Remember that any decimal I have inside of the radicand, I can rewrite. I look for place values. The 6, I look at the last number. The 6 is in the 100th place value. So I can write that over 100 for 100th. And then all I do is I drop the decimals to get 36 over 100. The model they have here is a 10 by 10 model. So 10 by 10, which is your 100, and a 6 by 6, which is your 36. So what this is the area is 100, and the area here will be 36, and the square that is created by an area of 36 is a 6 by 6, or 6 squared, and the area that is created by a 100, that's all of it, a 100 squares, is a 10 by 10, so it's 10 squared, and then our square root gets canceled by the squares, and we're left with 6 over 10. Be aware we can reduce this to 3 over 5. So 3 over 5 would be the best answer, but 6 over 5 is also a correct answer. Let's move this up. Now it asks us to calculate the numbers whose square root is. So this means that they already figured out the square root, and we have to figure out what's inside of the radicand. So to do this, let's just remember, and I'll give you a more simple example. If they said the answer was 7, they want to know the square root of what number will give me 7. Well, if we look at opposites, opposite of the square root is a square. So we just go backwards. So 7 squared gives me 49. And this 49 is what goes inside here. So essentially all we're going to do is take these numbers and we're going to square them, and we should be able to get our answers. So let's erase some of that. Okay. So it asks for 2a, what is, this one's the square root, so we just had to go 1.4 squared. We could also go 14 over 10, which will give us 100 on the bottom, and 196 on the tops, or we could have just went this route and got our 1.96. Either way, you get the same answer. This is 1, and the place value is in the hundredths, so that works. So let's look at B. 3 over 8, that is the answer to a square root problem. So to go opposite, we go square. Remember, we distribute that square into both. We get 3 squared is 9, and 8 squared is 64, and that's our answer. Okay, move this up. This is asking us to actually figure out what is a square root, so we'll do that. Get some more space here. Let's look at 16, or look at b, I mean. Square root of 1 over 16. You're going to want to demonstrate your understanding by going 1 squared over 4 squared. This one messes people up. So remember, 1 times 1 is 1, so that's the 1 squared we're looking for. These guys cancel, and I'm left with 1/4 as an answer. If you're dealing with decimals, you do this exact same thing. You convert that to a decimal by going tenths, hundredths, so I read it as 9 over 100, which can be written as 3 squared over 10 squared. Square gets canceled by the square root symbols, and I'm left with 3/10 as an answer. So essentially they're all going to be the same. When you're looking at questions like 4, the numbers look a bit bigger. The rule always applies. That's why it's a rule. We look at the last place value, and you write that as 9,025 over 100. So then you got to figure out, well, what number times what number will give me 9,025. For that, you'll use a calculator. It happens to be 95, but for those situations, you would use a calculator. For letter 5, exact same things we just did. What is the square root of 1, 4, 8, 8, 4 with no decimal place over 100? I find the square root of the top number, right, on a calculator. That's a little bit better. Now here, this is interesting too. When I start canceling out here, centimeters squared, this square gets canceled by that squared, right? Square root cancels a square. It's the exact same thing, and your answer is going to be in centimeters. So that we don't magically just get rid of the 2. The square root symbol actually cancels out the centimeters squared to leave centimeters. So that actually helps us here too. And then you can do the perimeter of that square once you know the sides. Move this up. And this question is just asking, a student said that the square root of this number is 0.04. Mistake I see sometimes with us is they think that this is a decimal. That's just a period. Don't stress about that one. Figure out if she's correct, and if she is correct, show why and explain why you think it is correct or is incorrect. So on questions here, 7, which decimals are perfect squares? Explain your reasoning. All you have to do is find the square root of them. If it gives you a perfect square, then it is a perfect square. So let's look at this one. 9 over 64. Can I write that as 3 squared over 8 squared? Yep. So this is a perfect square. Try to write each of these as this, decimals again. This will be the square root of 576 divided by, that's the 100th place value. So we know the bottom is 10 squared. And is there a number out there that when it times itself, you can have it as a square? If it does, and it does exist, then you could cancel the squares and then you get your answer. If it doesn't exist, then this one's not a perfect square, and that's for you to figure out. Now we get into something called benchmarks. So number 8, benchmarks, all we're doing is we're looking for perfect squares on either side of a number. So sometimes it's a little bit more confusing than it should be. So if I looked at a number line, and I looked at numbers close to 5.6, I know that 4, which is a perfect square, I get 2. I know that 9 is my next perfect square, and I get 3. Here's my halfway point between 2 and 3. 5.6, this would lay somewhere about this area. Somewhere in here. We'll say that's about 5.6. Right? So if this was 4, 5, 6, 7, 8, 9, this is about 5.6, which is about 2.3. So by using benchmarks, I can estimate my answer to be 2.3 because I use number lines. Try another one. So we know that our number line, here we go, the closest perfect square to 42 is 49, which is 7. The one to the left of that would be 6, because it goes 7, 6. 6 times 6 is 36. It's the halfway point. 42.8 is about here, and that's about 6. This is 6.5, so 6.7. And so the estimate is about 6.7 using benchmarks. So those are your benchmarks. And for this one here, we've got to realize that this is Pythagoras' theorem. You have a right angle triangles, so you can use a squared plus b squared equals c squared. This arrow here, which is not an arrow, but it looks like one, it's a right angle, always points to the hypotenuse, which is always going to be c. So you have a, you have b, you will go 2.5 squared plus 1.6 squared, and that will give me c squared. Whatever the answer is here, to get rid of this square, just like we did on every question up here, square root cancels a square, and because it's algebra, whatever you do to the right hand side, you must do to the other hand side. So if you cancel this square out, you have to take the square root of the answer of here, so 2.5 times 2.5 plus 1.6 times 1.6, whatever you get when you add those, you take the square root. You can use benchmarks, you can estimate, you can use a calculator, and that's how you're going to find C, and you'll do that for these next few questions. And on these ones, which are correct to the nearest tenth, tenth is the first place value, so 0.7, this is a tenth. So the nearest tenth is you're looking for the first place value. You figure out the answer and you say if it's correct or not. Okay, or not. So that's for you to figure out. Same with number 11. So to find two decimal places that have square roots between these two numbers, you just take a number. For example, we know that 16 squared is 4, so 18.8 squared would have to be between 4 and 8, because we know it's bigger than 16. And that's all they're asking here to do. So what you can do is essentially take this number, square it, take this number and square it, and then find some places in between it to see if that works. So if I would have taken this number and squared it, and this number and squared it, I would have got 16 and 64, and I have to find a number between 16 and 64 to match this question. So hopefully that video helped. Again, come for help if you need me. I'm available at lunch and after school sometimes. Good luck.